Writing polynomial functions given the roots can be kind of a headache. So let's take a look at question number 11. If we want to write a polynomial function, we first can start with our root of 5. Remember, all we have to do is plug that root into a parentheses with x minus. And so x minus 5 would be the first parentheses in our polynomial function. Our next two roots, 3 plus 2i and 1 minus 3i, actually come in pairs. Because of the complex root theorem, we know that for each complex root, we actually have a conjugate. So 3 minus 2i and 1 plus 3i included in our roots. And so we have to include them in our polynomial function that we're writing. So let's do the same thing with our parentheses. With x minus, we'll have x minus smaller parentheses here just to differentiate, 3 plus 2i. And we'll have x minus smaller parentheses, 3 minus 2i. And the same with 1 minus 3i. So x minus 1 minus 3i. And x minus 1 plus 3i. All right, so let's get down to it. We got to make this into a polynomial in standard form. So let's first start by trying to simplify those parentheses that have the minus 3i's in them. And we can multiply them two at a time. So let's multiply these two parentheses by themselves first. So we're going to get x squared minus x parentheses 3 minus 2i minus x parentheses 3 plus 2i plus 3 parentheses plus 2i times 3 minus 2i. Okay, that's a lot of stuff in those first two parentheses. Let's do the same for the second two. I'm going to try to make it a little bit smaller here. So we have x squared minus x times 1 plus 3i minus x times 1 minus 3i plus 1 minus 3i times 1 plus 3i. All right, so let's make these crazy parentheses a little bit better. So I have x minus 5, and here we're going to be able to distribute. So negative 3x plus 2xi, the convention is to put the I at the end, minus 3x minus 2xi. And then we have to FOIL these here, or distribute if that's what you call it. So we'll have plus 9 minus 6i plus 6i minus 4i squared. Some people can simplify that a little bit faster if they know how to multiply conjugates the shortcut way. Let's do the same with our second parentheses here. So we'll have x squared minus x minus 3xi minus x plus 3xi. And then we distribute these. So we'll get plus 1 plus 3i minus 3i plus, that should be a minus 9i squared. Whew, a lot going on here. So we got x minus 5, and let's get this simplified. So I'm going to use a different color here to cross out some like terms so we don't have to combine them. We've got positive 2xi and its opposite, negative 2xi. Same with these negative 6i's and positive 6i's. And so we're left with x squared minus 6x, and you can keep crossing off if you want to keep yourself organized here. Okay, plus 9. And then remember that I squared has a funny property. It turns into negative 1. And so negative 4 times negative 1 is going to be positive 4. Now we're starting to get there. Let's do the same with our second large parentheses over here. So we can cross out these. They're the same. Well, they're opposites. We've got positive 3i, negative 3i, cross them out. And so we'll have x squared. We'll have negative x minus x, that's negative 2x. And we'll have 1 minus 9 times negative 1. So negative 9 times negative 1 is positive 9. So we'll have 1 plus 9, which is 10. Looking a lot better. So I do need to simplify these numbers right here. So I'll have x minus 5, x squared minus 6x plus 13, and x squared minus 2x plus 10. Still quite a lot of things to multiply. So let's start by working from the left to the right. Let's distribute this x minus 5 into the x squared minus 6x plus 13. So we'll get x to the third minus 6x squared plus 13x minus 5x squared plus 30x minus, that would be 65. And we still are going to have to simplify this and multiply it to x squared minus 2x plus 10. Okay, so let's simplify our parentheses first. So we'll get x to the third minus 11x squared plus 43x minus 65. We have to distribute that to x squared minus 2x plus 10. All right. So a lot of multiplication going on. We're going to distribute x to the third to everything in the second. So that will be x to the fifth minus 2x to the fourth plus 10x to the third. Let's do the same with negative 11x. So we'll get negative 11x to the fourth, okay, plus 22x to the third minus 110x squared. Let's move on to 43x. So we'll get positive 43x to the third, okay, minus 86x squared. All right, so multiplying 43x times 10, we just add a 0, so that should be positive 100 or 430x. Let's do the same with negative 65. So we'll get negative 65x squared, okay, plus 130x. And then I'm running out of space here, but that should be negative 650. Whew. Okay, so it's really, really important that you cross things out when you work here. And so for our final answer, we should get, well, we have x to the fifth. It's our only to the fifth power. Now we have negative 2, x to the fourth, negative 11, x to the fourth. That's negative 13x to the fourth. And that's it. So minus 13x to the fourth. Go ahead and cross those out. Then we've got 10x to the third, 22x to the third. That's 32. So 32 plus 43 would be 75x to the third. And for our x squareds here, we've got some bigger numbers. So you can use a calculator if you would like to keep yourself organized here. I'm going to have a negative 110x squared minus 86x x squared minus 65x squared. And I'm going to get negative 261x squared. So let's cross them out. And for our x's, we have 430x plus 130x. That should be 560x. And lastly, minus 650. All right, we just found our polynomial that could have all of these zeros.